Welcome to the course on descriptive statistics with R software. You may recall that in the earlier lectures up to now, we have considered the descriptive tools which are used for a univariate setup. Univariate setup means there was only one variable, and we tried to measure the measures of central tendency, measures of variations, etc. only on one variable. Now, what will happen when we have more than one variable? For example, there can be two variables which are interrelated. So, the question comes that how to know whether the two variables are interrelated or not, and in case if they are interrelated, how to measure their degree of association. So, now from this lecture we are going to attempt to study the descriptive tools which are used for more than one variables. Then there will be two types of tools, one graphical tools and say another are analytical tools like as quantitative tools. So, in this lecture we are going to study on say univariate and bivariate scatter plots, which is a graphical procedure. So, now let us start our discussion here, and let me first take few examples. Now, for example, we know from our experience that if a student studies for more number of hours, usually he will get more marks in the examination. So, now if I try to take these two as variables, the numbers of hours of study and the marks obtained in the examination, then from experience we know that both these variables are associated and they are related. But you can think that if you have got a data set on two variables, how would you know on the basis of given values that whether the two variables are related or not, and in case if they are related, how to show it graphically and how to quantify the degree of association. So, the first example which I have just taken is that the number of hours of study, they affect the marks obtained in an examination. Similarly, we also know that when the weather temperature increases, for example during summer, then we use more electrical appliances like a cooler, air conditioner and so on. So, the electricity or say power consumption increases. So, I can say that the two variables power consumption and weather temperature, they are related, and their tendency is that as the temperature increases, the power consumption also increases. Similarly, in say another example, we know that weights of infants and small children, they increase as the heights of those children increases under normal circumstances. Right. So, now my question is this, from this data set, from this type of information, we have used our experience, and based on that we are trying to conclude these things. But my question is this, how to do it statistically, how to do it mathematically, and moreover how to show it graphically and how to quantify it. So, now I will be considering the association between two variables. So, I will consider two variables and I will first try to show you that what are the different types of plots available. So, now my question is this, that I have got the observations on two variables and both the variables are assumed to be related to each other. So, first question comes, how to know that the variables are really related, and if they are related, how to know what is the degree of relationship between the two variables. So, there are various graphical procedures like as two-dimensional plot, three-dimensional plots and so on, and there are some quantitative procedures also like as correlation coefficients, contingency tables, chi-square statistics, linear regression, non-linear regression and so on. So, we will try to study these tools one by one. So, now first let me try to describe the setup, that what are the variables and how the observations have been obtained. And now we are interested in creating the graphs. So, I simply assume here, suppose there are two variables and these two variables are denoted by capital X and capital Y, and a small n number of pairs of observations are available on these two variables, and these observations are denoted at x1 y1 which are occurring together, x2 y2 which are occurring together, and lastly xn yn which are occurring together. What does this mean? Suppose I take here x variable as, say here, height of children, and I try to take here y to be the, say here, weight of children, and now I try to collect the observation on these two variables like this. Suppose I take a child and I try to measure his height, and suppose this height comes out to be 100 centimeters. So, for this child number 1, the height is coming out to be 100 centimeter. So, I try to denote it, say here x1 is equal to 100 centimeter, and then I try to find out the weight of the same child, child number 1, and suppose this weight comes out to be, say here, 20 kilograms. So, I try to denote this first value as y1 equal to 20. So, now this x1 y1 which is here, say here 100 and 20, this is my first pair observation. And similarly, if I try to take a second child, say child number 2, and if I try to measure the height of this child, suppose this comes out to be 90 centimeters. So, this is going to denote the height of the second child. Height is denoted by capital X. So, I can denote the height of the second child by x2, and similarly I try to find out the weight of this child. So, weight is given by y and its value is given by small y. So, I try to write down the y2 which is indicating the weight of second child, and suppose we observe that this weight is suppose 17 kgs. So, now this x2 y2 which is equal to here 90 comma 17, this is my second pair of observations, and so on. We can say collect here more number of observation, and this observation will be given as 100 comma 20, 90 comma 17 and so on. So, this will indicate that this is the value of x1 y1 and this is the value of x2 y2. So, as soon as I write that there are n pairs of observations, that means these are some numerical values which we have obtained by experimenting the data or by observing the data in any phenomena. Now, after doing this, my first question will be, I would like to know whether there is any relationship between the two variables or not, and that I would like to judge on the basis of given set of data. In order to do this thing, we have a plot which is called as a scatter plot. And in a scatter plot, what we do, that we try to plot the paired observation in a single graph. How? For example, I have here two variables x and here y. So, I will try to take the value of here x1 and here y1, and I will try this point over here. Similarly, I try to take the value of here x2 and the value of here y2, and I try to plot it here. So, this point is the point x1 y1, and this point is here x2 y2. So, this is called a scatter plot. Now, This scatter plot can reveal different types of nature and trends of possible relationships. So, for example, we can broadly divide the nature of relationship to be linear or non-linear. So, here you can see that I have just plotted a scatter plot here and here. So, you can see here these circles here, they are trying to indicate the value of some observation, right. So, all these circles, they are essentially trying to plot the values of xi's and yi's. But if you try to look at the pattern in this graph, what you see, that you can see here that there is a sort of trend. I mean, the trend is that as the value of x is increasing, the value of y is also increasing, and this is happening more so over in a linear fashion. There is a sort of linear relationship. So, I can say here that by looking at the scatter diagram, I can conclude that the relationship in this case is linear. That means, there exists a linear relationship between x and y. Similarly, if you try to look into this figure, second figure, you can see here that once again these points are plotted here, but you can see here that these points are something like, they are not actually linear. They are not showing that there is really a linear trend, but the trend is something like this. So, this is indicating that the relationship between x and y is non-linear, right. After this, once we have decided that the relationship is linear or say non-linear, then how to see whether the strength of the relationship is say more or less. So, we are going to now consider here only the linear relationship, and similar type of conclusion will also be there for the non-linear relationship, but I will not consider it here in this lecture. So, if you try to see here in these two graphics, figure number 1 and figure number 3 on the left hand side. In case if you try to see here in the figure number 1, these points are concentrated inside this band, and in figure number 3, the points are concentrated in this band. And now, if you try to observe the width of this band and compare it with the band width of figure number 1, and you can see here that in case of figure number 3, the observations are scattered more than in the case of figure number 1. But in both the cases, you can see that the trend is almost the linear, which I am denoting with the red color. In both the cases, you can see here that the trend is nearly linear. But what is happening in this trend? In this figure number 1, you can see here that those points are very close to the line. All the scatter points, they are lying very close to the line in red color. Similarly, in the case of figure 3 here, if you try to see, the points are lying quite far away from the line. You can see here in the orange line, I am trying to denote the deviations. And when I try to compare these deviations of observation from the trend line or the red color line in figure number 3 and figure number 1, I can say here that the strength of the linear relationship in figure number 1 is more. Why? Because in figure number 1 here, the points are lying more close to the line, and in figure number 3, the points are quite away from the line in comparison to figure number 1. Now, there is another thing which you have to observe. In figure number 1 and say figure number 3, now try to observe my line in purple color. You can see here, as the values of x are increasing, the values of y's are also increasing. And the same thing is happening in figure number 3 also. As the values of x are increasing, the values of y's are also increasing. You can see here in figure number 1, this is my here x, this is my here y, and now if I try to take another x here, this is my here another y. Right. So, this is indicating that the relationship is increasing, or we call it positive. So, this is what I mean, which I have written in the title, strong positive linear relationship. That means the relationship is linear, and this is strongly positive in comparison to the relationship in figure number 3, where I am saying that the relationship is positive, but it is moderate positive and it is linear. Similarly, now in case if you try to observe in figure number 2 and figure number 4 here, you can see here in this case, as the values of x are increasing, the values of y's are decreasing. This is happening in figure number 2, and the same thing is happening in figure number 4. So, in this case I can say that the relationship is decreasing. Decreasing relation between, say here, x and y in both the cases, figure 2 and figure 4. Now, in case if you try to create here a line that is called trend line, you can see here this is like this, and in the figure number 4 this is like this. Now, if you try to analyze what are the deviations of individual observation from this line. So, if you first observe in figure number 4, these points are lying quite away from the trend line, you can see here, in comparison to the figure number 2, because in figure number 2 now if you observe, these points are very close to the line in comparison to figure number 4. So, I can say now here that in figure number 2, the relationship between x and y is quite strong, and since it is decreasing relationship, so we call it as a negative linear relationship, because the relationship is linear. And similarly, in the case of figure 4, I will call it as a moderate negative linear relationship. And similarly, in case if you try to plot x and y, and if you get no clear relationship, for example, it is happening here in figure number 5. For example, you cannot say here whether there is an increasing trend or decreasing trend, or say where is the trend, something like this. So, in this case, by looking at the scatter plot, I can say here there is no clear relationship, and even we do not know whether it is linear or non-linear, or even this is positive or negative. So, now in this lecture we are going to study the aspect of linear relationship. So, we will assume that whatever things we are going to do, in those cases the relationship between x and y is linear, and there will be two aspects, say graphical and say quantitative. Right. So, now what I will do, that I will try to take some examples, and I will show you that what are the commands on the R software, and I will also show you that how to execute them and how to understand the outcome. First, I am going to discuss here a command which is plot command. One thing which I would like to make clear here, that this plot command can be used to create the scatter diagram in univariate as well as bivariate setup. I had not covered it when I covered the univariate graphics, because I knew that I am going to cover the topic on plot. So, why not to cover it together, right. So, in case if you have only one variable, univariate case, then the data on that variable is stored in a data vector x, and then the R command is plot, P-L-O-T, and inside the argument you have to write the data vector x. Okay. Now, I try to take a simple example, and I try to show you here that how the graph will look like. So, I have once again taken the same example which I considered in the earlier slides, that we have collected the data on height of 50% and which has been recorded here, and this data has been stored inside a variable whose name has been given as height, like this. Now, I would like to plot this data. So, I give the command here plot and inside the argument height, and you will see here, you will get here this type of outcome on the R console. And my objective is not to show you here the figure, but I want to show you that how to interpret it. You can see here on the x axis, this is giving me the index. What is the index? For example, if you try to see in this data set, what is my first observation? This is my first observation. So, this is my here second observation. So, this index is trying to give the order in which the data has been given. So, this first observation will have index 1, second observation will have index 2, third observation 130 will have index equal to 3. And in this plot, what they have done? They have taken index here, they try to take the value of index number 1 and whatever is the value here of the x data. For example, here this is height, they will plot it here, they will try to take the index number 2, they will plot the data here somewhere wherever it lies. So, here you can see here on the y axis we have here the height. So, this is only a scatter diagram of one variable. So, from here actually you can have the information on say central tendency or say dispersion, if the data is more concentrated or it is more concentrated around a particular value. So, all these types of measures of central tendency and dispersions can be viewed from this type of graph. Okay. Now, I come to bivariate plots. So, bivariate plot means there are two variables and these are the plot which gives us the first hand visual information about the nature and degree of relationship between the two variables, whether the two variables are related or not, and if they are related, whether their relationship is linear or say non-linear. So, all this type of information can be used by this bivariate plot. So, in bivariate plots what we try to do, we will take two variables here x which will be plotted on x axis and say values of y variable which will be plotted on y axis, and then whatever are the values of say here x1, x2 and so on here xn, and similarly on the y axis all the values y1, y2 say here yn, they will be plotted here like this and they will try to show you the trend and degree of relationship. So, we will try to take some examples and we will try to see that what are the commands and how they have to be executed. So, now in order to create a bivariate plot, suppose we have two variables which I am denoting by small x and small y, in which the data of these two variables have been stored. Now, in case if I want to make a plot like on x axis I will have the value of x variable and on y axis I will have the value of y variable. This can be executed by the command plot, but now inside the arguments I have to give the variables x and y separated by comma. So, this is how we have to do. Now, there is another option available in this command which is here type. Just by giving various values to type we can create different types of graphics. For example, if I say type equal to p, then it will give me only the points which is the default value, and if I say here p is equal to l, this is going to give me the lines. So, you can see here I have made this p and here l to be bold way, which is indicating that what is the meaning. So, you can easily remember also, and if you want this point and line to both to be present, then I have to use the type equal to b which is coming from both. And similarly, if you try to use the type equal to c, then I will get lines which are only part of the b, because in B we have the points and lines both. And similarly, if I try to use here the command O, then I will get a overplotted, means the points and line are both are overplotted inside the graph. Similarly, if I try to take the type equal to S, then I will get a graph which will look like a stair steps. And finally, if I choose type equal to H, then this will give me lines which will look like as if I have created the histograms of this data, or there will be some high density vertical lines. So, now let me try to take an example and I try to show you that how this different types of graph will look like. But before that, there are some more options which are available in the plot command. For example, in case if you want to give a title, then you have to use the main inside the argument and you have to just give whatever you want to give as a title of the plot. Similarly, if you want to give a subtitle of the plot, then you have to use the command sub A. And if you want to give the title on the x axis, then the command here is x lab A. And similarly, for y axis title, the command is y lab A. And if you want to maintain the aspect ratio, that means how the graph will look like, should it be more stretched in the x direction or in the y direction, then this is given by the option ASPTHE. And if you give a numerical value to this thing, this will maintain the aspect ratio. And definitely, if you want to have more information, I will suggest you that please try to look into the help of this type command or say help on plot command. Right. Now, I will take a simple example to demonstrate how to use this command and how the graphs will look like. As we have discussed that we know the number of hours of study of a student, this affects the marks obtained in the examination. So, the number of hours of study and the marks obtained in the examination, they are related. But this is from my experience. So, we have collected the data on 20 students, that how many hours every week they have studied, and finally, how many marks they have obtained in the examination out of 500. And those marks and the number of hours of these 20 students have been recorded as follows. That for example, if a student has studied 23 hours per week, then he has got 337 marks. If a student has studied 25 hours every week, then he has got 316 marks and so on. So, the first row is denoting the marks and second row is denoting the number of hours per week which a student has studied, and this data for 20 students has been obtained here. So, now what I do here, first let me try to compile all this data into data vectors. So, I try to create a data vector here marks, in which I try to store all the observations which are given in the first row here, this and here this, and which is here. And now, in the second case, I have taken a variable here hours, in which I have stored the data which is given in the second row here, and I have created here two data vectors, marks and hours, and I will be using this example again and again. So, now I have explained you the genesis of this data set. Now, I would try to simply make a plot of these two data vectors, hours and marks. So, I will be using here the plot commands for the bivariate plots, which was plot xy. So, now I will say here plot, inside the arguments I will try to give the two data vectors hours and marks separated by comma, and this will give me here the graphic like this one. So, you can see here that these are the data points, and by looking at these data points you can see here that there is going to be a sort of linear trend. Trend means that most of the points are going to lie nearly on a straight line. Now, in case if these points are lying close to the line or away from line, that will give us an idea about the strength of the relationship between marks obtained in the examination and number of hours studied. Right. Now, in case if I want to change this type, then now I am going to use here a type which is here L. If you remember, this L was used as a type to create the graph with lines. So now you can see here, once I try to do it here, I get here a graph like this one, in which all those data points like this one here, and they are interconnected by such lines and so on. And if you wish, you can compare it from this curve. If you try to make it here this and so on, connect them by line, that will give you a line plot. Similarly, if you try to choose here the option for type equal to B, B means both line and point. So you can see here, this is the combination of the first two graphs that we have obtained here. Those points are here, all those points are here, and they are connected by these lines like this, and so on. So this is how you can obtain this type of plot. Similarly, if I try to use the option of type equal to O, O means overplotted. What do you mean by overplotted? In the earlier graph, if there are 2 points here like this, they were simply joined like this. But now I am saying that there are 2 points here like this, and the line will cross through like this one. So you can see here, these are the points and so on, which are just joined from point to point. So the line and those dots both are overplotted. So this type of graph will again give us a different type of information. Now in case if I use the type H, so we have discussed this. H means that this is a sort of histogram or say high density vertical lines. So you can see here we have this data here like this, and this data has been joined on the x axis like here this. So this is another type of plot which can be obtained by using the type H. And similarly, if you want to create a steps type of plot, then use the type equal to S. And if you see the plot which we have obtained here, these are my data points and so on. You can see here first that what were my data points in the first curve. You can see here this point is here like this, and the same thing is here like this. The points are here and here, and now they have been joined by say stairs type of plot. And similarly, you can see here these points are going like steps, means you have seen that when we climb on the roof, then there are stairs like this one. So that is why this plot is called as a stair steps type plot. And now in case if you want to make it more informative, suppose you want to add here the title of the plot, titles on the x and y axis. So you have to use different options. And if you remember, we have discussed these things in more detail when we have discussed the graphics in the case of univariate data. So for example, now exactly on the same way, suppose I want to give here a title like marks obtained versus number of hours per week. So we have discussed that this can be given by the command main. So I try to write here the main is equal to the title inside the double quotes. And similarly, if you want to give here a title on the x axis, suppose I want to give number of weekly hours. So then in order to do this thing, we have the command xlab. So I try to give whatever the title I want to give on x axis by writing xlab is equal to the title inside the double quotes, and this gives me here an outcome like this. Similarly, in case if you want to have a title on the y axis, suppose I want to give here marks obtained, then for that we have the command ylab. So I write ylab is equal to the title which I want to give inside the double quotes, and this outcome is given over here. And similarly, there are some other options which I would say that please try to look into the help menu and try to see here. So now I will try to show you that how these graphics using the plot command are constructed inside the R software. So let us come to our software part. So you can see here that I already have stored the data HOURS, hours, and on the marks you can see here like this. This is the same data that we have obtained in the example, you can verify it. Now, I am trying to say here plot between say here marks and say here hours, and as soon as you enter it you get here this type of graphic, right. So, you can see here this is the same graphic that we have obtained. Now, in case if you simply try to change the order of the variable here, you can see here at this moment marks are coming on x axis and hours are coming on y axis. Now, suppose I want to interchange it, in place of marks I will give hours and in place of hours I will give the marks. So, I will type here plot hours and marks, and now as soon as I enter you can see here that this graphic is changed, you can see here like this. So, now I will continue the same command and I will clear the screen, but I will try to show you that what are the different options which you can use using the type option. So, if you see here, this was our first option was type equal to L, by which I will get the lines. So, now you can see that as soon as I press enter this graphic will change, you can see here this is now L. And suppose if you want to have line and points both, then I have to give the type equal to B. So, you see here you get a different graphic, and similarly if you want to use the overplotted option by choosing the type equal to O, small o, then as soon as I press enter I get this curve. This is the same graphic which we have seen inside the slides. And similarly, if you want to have a histogram or say high density lines, then using the type equal to H we get here this type of command, you can see here. And finally, if you want to have a stair type graphic, then I have to use the type equal to S, and as soon as I do so I will get here an graphic like this one. So, you have now seen that creating graphic is not difficult at all. Now, suppose if you want to add some more features, like as there are some default features that whatever is the name of the variable that will be coming on the x and y axis. But suppose if you want to add titles on x axis, titles on y axis and main title, then you have to use the same command. So, you see here on my slides that I had shown you here. Now, I will try to copy this command and I will try to paste it on the R console. So, you can see here this is coming like this, and now you can see here as soon as I have pressed the enter, this graphic is changed. Now, you have the titles on x y axis as well as the other titles, and similarly, in case if you want to change the colors, this is also possible using the options, but definitely I have shown you the basic operation. You can make it as beautiful as possible, as informative as possible, whatever you want. So, now I would stop in this lecture, and in this lecture I have given you an idea of the plot command. I am not saying at all that which of the command or which of the graphic or which of the type is the best. It depends only on you people or the experimenter. The experimenter has to decide, or you people have to decide what type of information you want from the graphic and which is the graphic which is most suitable to provide that information in the correct way. And this also comes by practice and experience. So, at this moment the objective is to learn how to create graphics and how to make them more informative, more interactive using the R commands. So, you please take some data set, try to experiment on it, try to give different types of option, try to create the plots and try to see what type of information they are going to provide. Try to take different types of types and you practice, and we will see you in the next lecture. Till then, goodbye.